So in this video, what we're going to do is we're going to look at how to figure out, well, how to answer questions like this. How many possible solutions are there? When I say solutions, it means when you solve a triangle, all the answers, together, that's a solution. All right, so finding all the other three parts. Okay, that's the solution. So here is the big old table that you can't find in the book. First, you look at if it's this or this, and then you make your decisions based on that. All right, how many possible triangles could there be? Well, if it's this scenario, there's none. If it's this scenario, there's one, and so on. So I felt like I wanted to make what's called a flow chart, kinda. I was pretty imprecise about it. But the flow chart, I think, is better than what's in the book. If I can get it. There you go. All right. So what you do is this. So as I walk through the three problems that are on the Smartboard file that we worked on in class, I'm actually going to go back and forth between these two things. All right. So actually, let's look at this. So triangle ABC. We have big A is 125, the angle is 125, little a is 35, and little b is 32. So maybe it's helpful to draw the picture and to put in what we know is told to us. Okay, so I'm not going to draw it. No, might as well. Okay, I'm going to draw it like there is a triangle, just so it looks like a triangle. All right, 35. It's got to be little a because they're across from each other. And then B is just got to be, let's say B is right here, 32. Okay? So let's see if that's even possible. Okay, so what we do is we go to the flowchart. Is it acute or obtuse? Well, it's obtuse. So we go down this path. Right? And we think, all right, it's obtuse. Is the side opposite the known angle greater than the other known side? Well, yeah. The side that's supposed to be opposite, which is A, is bigger than the other side that we're told. So remember, the assumption is that these triangles are named in kind of the standard way. Trying to make it kind of easier for you, and always labeling the sides and angles the same way so you know how everything is related to each other. So little a is supposed to always be across from big A. All right, little b will be across from big B, which is not labeled, but it's the one over here on the right, the way I do it. All right, so yeah, little a is bigger than little b. The side opposite is bigger than the other known side. So yes, that's a yes. And there is one possible triangle. All right? There's one possible triangle. One solution. All right? And the exercises in the book, you would go ahead and find that solution, which in this problem would be pretty similar to the one we did today in class. This guy right here. The whole thing. This guy. So what we did together in class, that would be pretty similar. Okay? So let's do another one, maybe. All right. Four minutes. All right. So this one. Triangle ABC, A is 25. So right off the bat, we look at the angle A. We say it's acute. All right? So it's acute. So we go down. Let me do this. We go this path. We go down that path. It's acute. All right? Okay, is the side opposite the known angle greater than or equal to the other known side? Okay, so the opposite side is the A, so I guess I could draw it. We have 25. This is like 25 degrees. We have 5 is A, and B is 10. Okay. So going back to our little flow chart, opposite side bigger than, greater than, or equal to the other known side? Yes, it is. The opposite. Oh, no. What am I saying? The opposite side is less than the other known side. 5 is less than 10. All right? So then we go, so it's no. So we go down this path. All right? And this is always the hardest one because there's 3 options. Then, because now we have to do some math. Oh, no. We're not just following the paths. All right, so now how does A compare to B sine A? So we actually have to take, do math. We have A, A is 5, and we have to calculate B sine A equals 10 times the sine 25 degrees, which is approximately equal to, if I get it, hold on. Okay. 10 times 25 sine. Okay, 4 and change. So it's 10 times 4.2, or point. So that is smaller than A. Or in other words, A is bigger than 4.2. A is bigger than the 4.2 we just calculated, so it's greater than. So it's 2 possible triangles. All right, so we calculated A was 5. Well, we didn't calculate that. That's given. This is 4.2, so it's greater than. So it's 2 possible triangles. All right, so last but not least, you see. All right, so let me erase all this stuff. Okay. Okay, so A is 50. Big A is 50 degrees. Little A is 5. Little B is 9. All right, so it's a acute angle. What we know is acute. So we go down that path. It's a 50-degree angle is what we know. The side opposite, greater than or equal to the other known side. It looks like it is not. The opposite side is not greater than. So we got to go down this path again. And it's a harder one again. Because, once again, we're going to have to do a little math. All right, so the opposite side is 5 again, for some reason. And then B is 9. Yeah. Okay. Oh, I lost my train of thought. Oh, yeah, here we go. So we got to calculate B sine A again, because we have a scenario. We have, well, this time it's 50 degrees for A. That's 5. This is 9. Okay. So it's an acute angle, and then the opposite side, A, is smaller than the other known side. So we actually have to calculate. We have to calculate 9 times the sine 50 degrees and see how it compares to the A. Okay. And here would be drop the marker. Good job. All right. So we do 9 times 6.9. Okay, so what that means is, actually what this means, that means that side, that height right there, is 6.9, but this side is only 5, so the way I drew it is not how it is. There's no solution. This A is 5. This is 6.9, so it's less than. The 5 is less than 6.9. There's no possible triangles. That opposite side A is not long enough. That doesn't make any sense. The given information is invalid. There's no way. There is no solutions. No possible triangles could have these three measurements. Okay. Oops. Okay. Oh, what did I just do? I deleted the whole page twice. I'm not very smart. I meant to do that. Okay. Anyway, there's no solutions because this side is just not long enough. It wouldn't be long enough. Or this angle is too big. If we had this, the 50-degree angle was actually a lot smaller, maybe the math would work out. So what do we do to find both solutions? So that's the hard part. So what you're really asked to do in the exercise in the book is what I just did, and then if there is one or two solutions, actually figure out what those one or two solutions are. And so, well, if there's one solution, it's exactly like what we've already done. Okay. If there's two solutions, what do you do? All right. So you start doing the problem. All right. So we have, this is the problem from before where there are two solutions. So what you do is you set up, all right, you have to find, well, let me draw it first. We have 5, we have, I'll put it down here, we have 25 degrees. All right, so it's A, B, we got to find big C, little c, and big B, okay? So what do? We do sine of B over 10 will give us sine of 25 over 5. Okay? So we just start doing a problem as if it was a regular problem we were doing before. Okay? So you set it up. Maybe pause and figure out why that's got to be the case. That's what we're doing today in class. And so we get sine of B equals 10 sine of 25 degrees over 5. Okay? And when you crunch the numbers, you get 0.845. So you get sine of B equals 0.845. That should be pretty accurate. So I'll do 4 decimals, I guess. Sine of B sine of B equals 0.8452. Okay. And then I do inverse sine, and I get 57.7 degrees. So I get B equals 57.7 degrees. Okay. Now what's up is that that's about here-ish on the triangle. So this is saying that you have, okay, so I've got the right triangle trigonometry. I know this is not the triangle that's up here. I'm just using this as a visual aid to walk through this next idea. So this is the point, this is y equals roughly 0.84. All right? This would be y equals 1, right? So this seems plausible. It's about right. This right there is 0.84, 0.85-ish. Okay? How did I know to draw it there? Because I got this angle. That's 0.577-ish. Okay? Round and nearest whole degree, that's it's 58 degrees. Now look at the unit circle. There is another angle between 0 and 180 degrees that has roughly that same y value. This also has y about equal to 0.8452. All right? What is that? What is that angle? The other possible value for B, other B, right? The other possible value, this is why SSA isn't a thing, is because this property of sine. Sine of B equals this, has two solutions, all right, between 0 and 180 degrees. Why do we care? Because that's the possible solutions for, that we're working with here that could be in a triangle. What is that? This is what you always do, and if you look at the unit circle here, what you always do, the other B could equal 180 degrees minus the angle we just figured out. All right, so let's see if I can do this right, because I screwed this up. This is 123.3 degrees. No. Yeah. Okay. So that's the other value of B, and so since we're about out of time, basically what it boils down to, or at least the video is getting too long, I can make this video as long as I wanted to, but you guys are probably out of patience. You would finish the solving of the triangle, all right, like we did today in class, like I did in the video yesterday, and you get one triangle. I'm not going to write it out. You get a triangle there, and then you finish that using, finish the solving of the triangle here. I don't know why I'm saying the solving. That's ridiculously wrong English. Finish solving, and you would do it twice. You got two triangles. You finish solving with the 57.7. You get answers for that. You get finished solving with the other B, the 123.3, that you always do this to figure out the other possible value for B, and you finish solving it, and you get different answers for C and C. There you go. We'll have some time in class to do that, but that's how you handle those.